Assalamu alaikum. My name is Hanan Ahmad and my roll number is 21TE25. Today we are going to discuss digital signal processing lab number 2. Basically in this lab we have to perform and plot discrete functions. So in the task number 1 we have three constants n0, n1 and n2. The values assigned to these constants are n0, n0 is equal to -1, n1 is equal to -3 and n2 is equal to 3. So we have condition that is n is equal to n1 to n2, and we have the condition that we have to plot x is equal to n minus n naught is greater than or equal to 0. So plotting this x function we use stem command. As we can see, there is a range of -3 to t3, and by applying this condition n minus n naught is greater than equal to 0. Yeah, it means it must be 0 or greater than 0, as we can see. In the task number 2, we have same functions, same conditions, but changing the value of constants, as n naught is equal to 1, n1 is equal to -5 and n2 is equal to 5. So the given condition is x is equal to n minus n naught is equal to 0, and must equal to 0. And we are using stem command that is used to plot the discrete functions. When we run this code, we obtain this graph. As we can see, it plot graph on 1 and obtained simple 1 value. In the task number 3, n1 is equal to -3 and n2 is equal to 3, where n is the total range -3 to 3, while the given condition x is equal to 3 power 0.5 into power n, and we are using same command stem for plotting the discrete function. When we run this first code, we obtained this graph, as it is decreasing graph, as it ranges from -3 to 3 and graph is decaying. So it is basically decaying function. For the second part, we have n is equal to -10 and n2 is equal to 10, and the range is -10 to 10, and the given function is x equal to 3 cos 3 pi n plus 5, that is cosine function, and we are using stem command to plot this discrete function. When we simulate this code, we obtain the following graph. As we can see, it also shows impulses from positive sides as well as negative sides. The main reason is that we are plotting cosine function, and we know that cosine range of cosine is -1 to 1. Basically, it is a sinusoidal function, therefore it is also shown for positive side as well as negative side. In the task number 4, first we define a function x that is equal to unit impulse n0, n1 to n2, where n is the range varies from n1 to n2, where x condition is x is equal to n must equal to n naught, and end function we are using to call the previous function that we described above. While we putting the values for calling function, we assume that n naught is equal to 0, n -5 and n2 is equal to 5, and we are using stem command to plot this function. As we can see, when we simulate this code, only one line is obtained, that is basically describes that it is unit impulse, because in unit impulse we have only one line. In the task number 5, we have to plot unit step function. For this we assume x is equal to unit step, where it varies from n comma n naught. In this function we are using if loop, if else command, where x condition is equal to n greater than or equal to n naught. It means that n naught is equal to 0, so n must be greater than 0. And at last we are using end command that basically complete the function. After this we calling this function, let's assume value of n range from -5 to 5, and x is equal to unit step n is n and 3, where n naught is equal to 3. And after this we using stem command to plot this discrete function. After simulating this code, we can see that value of n naught is 3, so we are using only unit impulse is formed greater than 3, must 3 or greater than is equal to 3. In the task number 6, we have two functions. One is the unit step function while the other is unit impulse. We describe x1 is equal to unit step and x2 is equal to unit impulse. We have to add both signals, unit step function and unit impulse function. To display the values, we are using display command, display of x. When we simulate this code, we are obtained these values 0, minus 3, 0, 0, 0, 0. And in the second part that are same, but in this task we have to add three functions. First one is unit step and second is unit impulse and third one is also unit step. So for adding we are using x is equal to x1 plus x2 plus x3. For display the values we are using display command DISP bracket x. By simulating this code, we are obtained these values 0, 0, minus 1, 0, 0, 0, 0. So in the task number 7, we are using flip command that is used to flip the function. For this we have range minus 3 to 3 where the value of x is this. We are using subplot command and the other stem command plot the discrete function and also labeling title. Well, after this we are same using subplot command, then stem and title. The obtained function is, as we can see, the given signal is flipped. In the task number 8, we define an array that is signal is equal to 1 to 7. In this function or task, we have to scaling the signals, where scaling factor is equal to 2. We use scale signal command. After this we are using plot command to plot the graph and also adding title on the circuit. When we simulate this code, we are see that we can obtain two values difference as blue and red line. In the task number 9, we define a time range that is equal to 0 to 1000 difference of 10. In this task we have to use shifted property of the signal. For this we have sine function and we use this shifted function. After this we are using plot command to plot the graph, hold on command and also use legend command. While we simulate this code we use obtain this type of graph. So in the task number 10 we have to plot zero order hold function. For this we define a time as well as frequency while the given function is sine. So we define a time interval 0.1 as well as frequency. After this we are using for loop and we use end command to complete the loop. After this we using subplot command. Plot command also use plot command that is used to plot the graph for continuous signal. After this we use stem command. We are using to graph the discrete functions. While we simulate this code, we obtain the following output. As we can see, in the upper part we obtain the continuous signal, while in the second part we obtain the discrete time signal that is zero order hold. So in the task number 11, we have input signal 1 to 5. We describe time function that is 0.1 to 0.5. We describe output signal. For loop is used and end command is used to complete this loop. After this we assume the time input that range from 0 to ts. For this we subplot command and after this we are using stem command. Basically stem command is used to plot the discrete function and we give some title input signal. After this we use plot command. Basically plot command is used to plot the graph of our continuous signal and we also titled this graph as output signal. While we simulate this code we obtain these outputs. As in the first part we are using discrete signal, and in the second we are using continuous signal.